Hello, everyone. I'm Hardik from LearnWeb3, and welcome to another workshop. Today we have Daria from Subsquid talking about data indexing. A lot of questions about that on our Discord recently. Probably there's a lot of things we hyped about with Unibot and whatnot. Um, but yeah, excited for this. Would love to see what these guys are doing, and happy to be able to host them over here. Thank you so much, Daria, for coming. If you could give a quick intro, and then yeah, let's get started. Oh, Daria, I think you're muted. Sorry.
Okay. Hi, everyone. So I'm Daria, and I am Developer Relations Engineer at Subsquid. And today I am doing a workshop on how to index ERC-20 transactions with Squid SDK. So this workshop is going to consist of introduction to Subsquid. So I'm going to tell you about what we're doing and what we're providing. And then also I'm going to briefly show you the architecture. And then I think the longest part of the workshop will be building a squid that indexes the transactions. And we're going to start from like a simple template. And in the end, we're going to have like a ready solution where you can look up any transaction you want. So let's get started. So Subsquid is a full stack indexing SDK, and it's specialized on decentralized data, which is fetched from the archives. And we also provide a hosted service where you can host your squid. So the data is completely free. So if you host your squid locally, you don't have to pay anything. And we also have a hosted service in case you want to host your squid with us. And so our goal is to solve the accessibility problem with blockchain data, because usually when you need to fetch data from the blockchain, you have to do like an RPC call, and that's really expensive and really slow. And if you have a big amount of data you want to fetch, basically we're trying to make it easier and faster. So the architecture goes the following way. We have the open source SDK, which provides the data from our data lakes, which are decentralized data archives of on-chain data. And we also provide the database. So the main difference from, let's say, the graph is that with Subsquid, you can hook up almost any database to your squid. So we also support S3 and BigQuery. And we provide an out-of-the-box GraphQL API, so you can make a squid, and then, for example, you have a front end like app in React, you use like a Apollo client, you make a query, and you have all the data you need. So this is the simple schema how we're going to go about indexing the transfers. So we have the transfer event that we want to capture from on-chain. So first we're gonna define the schema, which will define how our data looks and also how we process it, and how it looks at the end, like API endpoint. And we will define the data selection criteria in the processor. And finally, we will set the processing logic in the main file, and then we'll be ready to run our squid and process the data. So let's start. So first, you might want to, I hope everyone has Docker and Node installed, because we need Docker to run the squid, and also we need squid CLI, so I'm gonna give you the link to the command in the chat to install the Squid CLI, and also the link to the prerequisites. So if you're following, you can go to open the docs link and then go to the minimal EVM indexer. And this is the minimal template, which indexes all of the transactions to the burn address. And we're going to start from that, and we're going to add into it and make the ERC-20 indexer in the end. So let's start. First, we're going, so did everyone install the command? Okay, let's give maybe like a couple of minutes. Yeah, if you guys have any questions, also feel free to send them in the chat. Okay, let's give like a couple more seconds and then go and start. Okay, so we're gonna scaffold the project from a template. Okay, hitting up doc. Yeah, it's like the first time always like the slowest. Okay, so you guys might want to run this command to download the template, and you do. So I'm gonna go to my folder for projects. So you do sqd init, and then the name of the squid. So let's say index. Okay, ERC-20 transfers. And then -- template EVM. So this is going to download us. Can you zoom in? Yeah. Probably is better. So yeah, this is going to download the EVM template, but we also have a template for substrate, so you can also index the non-EVM chains. Okay, it already exists, so let's do just transfers. Okay, and let's open it. Okay, probably also need to zoom in here a little bit. It's huge. Okay, so let's start from the schema file. And here is where we set up how our data is going to look. So in this template, if you go over to main, you'll also see that we use this model in the further code. So we're going to start from this, and also don't forget to run npm CI to install the dependencies, because I always forget that. This is the same schema as the graph. Yeah, I mean, in graph you also use GraphQL, so you can say that if you want to like port the schema, then you can just copy paste it, so it's the same. This is, I think, the only component you can copy paste, but in general, if you want to migrate from the graph, it's pretty easy, and we have a tutorial. Do you need it? No, I think the computer will last. So okay, so the dependencies have been installed, and let's start from schema. So basically, the idea is that we only want to index the transfers. So for that, we need two main components. We need to keep track of all of the ERC-20 contracts, and also then of all of the transactions that are going to those contracts. So first we are going to define a contract. So it's going to be contract entity, and the contract is going to have the ID. Like the default is Postgres database, so we're going to use that. And then the deployment, this will index all ERC-20 transfers, yes. So all of the, like, I'm going to elaborate further on this, but yes, basically all of them. But when you see how we determine if it's ERC-20, you might understand why, like, maybe some are going to miss, like, TEDOS or something. Deployment height, so this is going to be the block number. And then next is going to be the deployment transaction. So this is going to be the transaction hash. And we set the string, and then we also want to keep track of the contract address. What else do we need? We are going to duck type to like guess from the bytecode if it's ERC-20. So let's do an is ERC-20 attribute, and we're also going to we also want to keep track of the transfers. So let's define the transfers. Transfer entity. So we need the same thing. Okay. Thank you. Also, this should be camel case. Okay. So we have the same thing, ID. We also want the contract. Then we probably want to see from, so who sent the transaction and to whom the token was transferred and value. And then, okay, let's forget the entity. And we also want to keep track of the transfers here. So this could be transfer derived from the field contract. Okay. So this is going to be a schema. Looks good. And now we can run sqd code gen command. So this will generate the, okay, what is that? Okay, remove the ID. So, okay, now schema I'm looking a bit different from the graph. I don't think I've ever seen derived from. What does that do? So derived from is because we want to keep the array, keep track of the transfers here. So this is why we want to have the derived from, so that we know that we're keeping track of this entity in here. Okay, so now let's run sqd code gen. Oh my god. Not okay. Save. Now it should be good. Okay, perfect. So we're done with the schema. And next we are going to go to processor.ts, where we're going to set which data exactly we want to get from the archive. So first we have the set data source, and that's basically sets the lookup archive. So in this case we have the Ethereum mainnet, but you can also add Polygon and any other EVM network. You can find it in the docs. And we also have the chain, because when we catch up to the latest block, we want to start processing the real-time blocks. So the set finality confirmation, we're going to leave at 75. And so where we want to actually change things is set fields. So from the transaction, we want the from, value, and true. That looks good. But we also think that we want to add trace. So this is going to tell us everything that the EVM executed, and we can add any type of trace. But in this case, we want to see the create trace, because we want to see if when the ERC contract was deployed, and then also we want to see that transaction. Okay, this needs to be an object. Okay, cool. And then we also want to, in the trace, we want to see the create code and the address. So code going to be true, and the create result address is also going to be true. So this way we see the bytecode of the contract, which we're going to use to guess if it's an ERC-20 or not. And we also get the bytecode, the result address that we can keep, so that we can keep track of the contract. And we also want to add the log from the event, because this way it's easier to fetch what the value of the transfer and from whom and to whom it was transferred. So we're gonna say that we want topics topic 0 to be so this is where we can actually benefit from our ABI. Let's see, we have the ABI. Oh, we don't have the ERC-20 ABI. Okay, so give me a sec. Let's go here. Can I guys send you like the whole thing? Because I thought the template provides the ABI, but maybe probably not. Okay, I think that works. So you guys need to copy this ABI and go to the ABI folder and create erc20.json, because we are going to use this ABI for duck typing the contract and also for getting the right event. Okay, thank you. For the GitHub link. So after you have the ABI, you can run in your terminal skg typegen, and this is going to give us the typings from the ABI, and it's going to get saved in the ABI folder. So here we go. So now we can import the ABI. So we can say that we want the only the logs of the transfer event, and we do this by saying erc20.events.transfer topics. Okay, and we can get what is topic 0. Topic 0 is the kind of the name of the event. So you can, I think, so if you wanted to do, let's say, ERC-20 approvals, you can do this, and this will give you all of the approval logs. Okay, and also we need to get rid from add transaction to the zeros address, events from the ERC-20 contract. Yes. Well, it's going to be all of the transfer events. I think you could, if you only do just add the topic, because either like non-ERC-20 contracts can have the same topic if they have a transfer event, and they also have the same function signature. So if you just say, for example, that you want to index like a certain event or a certain or transaction to the certain signature, that's not going to give you only the ERC-20 context. So we need to do some extra step to make sure it's only ERC-20. And we need to get rid of add transaction because we want transactions to all of the addresses, not only to the 0. So that looks... yeah, exactly. Okay, because ERC-721 has also the transfer event. Yes, exactly. So if you wanted to change this to ERC-721 later, you can actually easily do that. Let's get through. Oh my god. Okay. So this looks like we're done here. So let's go over it again. We have the create trace from the block, and then we have the log from the transfer event. We have the fields for transaction, and we have the fields from the trace. Yeah, and set block range. So we start from 6 millions. You can, if you leave this out, you're gonna start from 0, but let's, for the sake of time, start from 6 million. But if you feel like, yeah, you can also get rid of that. Okay, and now we need to do an extra step so that we actually make sure that our contracts are ERC-20. So let's make a new file in the source folder and name it is ERC-20.ts. Okay, so let's go to that file, and we're going to... Sorry, I think I'm having a bit of a hard time understanding the flow here. Maybe I don't have... What is the trace? And generally also, what is this processor? So the trace is basically everything that the EVM executed. So if you call a transaction, so imagine you have like a fluidity function, and it might have like another function inside of it. So if you have a transaction and inside of it there's also another transaction, this is all going to be in the trace. So it's like a tree of everything that the EVM executed. And in this case, and they have 4 different kinds. I think it's like create, call, and the other 2 is like reward, and the last one I don't remember. I think it's like self-destruct one. Yeah. So in this case, we want to only get trace of the type create, because we get this trace when the contract is deployed. So this way we are getting all of the deployment transactions of the ERC-20. But for example, you could also do a call here, and then you'll get everything that EVM executed, like calling some other contract. Okay, let's continue on the... So here we're going to determine if the bytecode of the project has all of the signature hashes of the functions that we want. Okay, so we are fetching transactions which have event transfer, and also tracing each transaction back to its deployment, but not necessarily every transfer includes it. Yes, so we're doing 2 things here. We get the traces, which give us all of the create transactions, and we also get the logs, but we get the logs from also every transaction. So basically we get every transaction that has this event emitted. So those are like two different entities. So they're not. We get like a list of for each block. We're gonna get an array of traces and an array of logs, and they might have different transactions. So we're gonna actually process them separately. I will show you later, so it's gonna be more clear. Yes. So I think my confusion is whether this code is indexing two separate types of transactions or indexing one type of transaction. So in the end, the data that you get is the transfer transactions. But this processor also, this particular processor is indexing two types of transaction, the deployment one and the transfer one. And we need to index the deployment one so that we make sure later that we only look at the ERC-20 contracts. So I hope that makes more sense. So let's continue, and we need ethers here from ethers. And we also want to again import the ABI ERC-20. Okay. Oh, sorry, forgot the import. Okay, so let's write the function that is going to determine whether the deployed, we're getting all of the deployment transactions. So this function is going to actually say if this deployment transaction is of the ERC-20. So this is how we're going to do it. This is ERC-20, and we are going to take a string. We're going to take the bytecode of the contract that is a string. And then what we're going to do is we're going to go through each ERC-20 function and check if this bytecode includes the signature of that function. And if it includes every signature, then we are going to conclude that it is an ERC-20 token. So as you can see, if, for example, you wrote an ERC-20 token and didn't include one of the functions, yes, it's not going to include it here, but you can change it to maybe be less strict. Let's say like if the 80% of the function signatures are contained, you can conclude it's in ERC-20. So we're going to want to loop through each function name and check the functions. And then we're going to check if the bytecode includes this one. So let's say that red function sig hash equal to just a comment here, there isn't 100% surefire way to determine if a contract is ERC-20 or not. So this approach, I believe, can still yield false positives. Yes, exactly, because actually when I was working on the big data set project recently, I needed to index like all of the contracts, and we also have like a field in the data set where we have the kind of the contract. So we have like ERC-20, ERC-721, ERC-1155, and yes, sometimes that field was like left unknown because we couldn't say if it is a 100% that kind of token. Actually, what I found useful is sometimes the bytecode can include the function signature, but not like a full one. Maybe it skips like a 0 at the end. So you can like add this like slice 2 to 10. Then it's going to be like a little bit more forgiving, because like I manually checked that and I'm not sure like what the reason is, but that sometimes happened. So, and now we check if the bytecode is not doesn't include the function sig hash. Then we return false. And then otherwise we can say that it's true. I think that's like if you're doing something like this, I think it's like fairly okay way to do this. Okay, and now we are going to go to the main file. So this is where we are going to save the data and to the database, and also where we're going to determine if it's like an ERC-20 transaction or not. So as you can see, we don't have the burn entity anymore because we generated the new one. So we need to change it to contract and transfer. And let's get rid of all of this. Yeah, let's just remove everything. It's faster. Okay, so now we are going to do 3 things. We first are going to fetch all of the contracts that we already indexed from the database, and we are going to save them to an array that we can check to a map that we can check against that we can check against, and we're also going to create an array of new contracts that we haven't seen, so that we can check against those, and that we can also later save to the database. So let's say that we have the known ERC-20 contracts. So those ones we already saw. And it's going to be a map. And we're going to okay, I'm going to do this and then I'm going to look at the questions a little bit later. So this is going to be okay, let's first do the array, sorry. Array, and this is going to be array of contracts. And so this is the array of contracts we have previously seen. So we want to say so here we have the database as an input, and this is the context. So we can say context store.find and we want and we want to see everything, every contract where ERC-20 is ERC-20 true. So it's, is ERC-20 field is true. Okay. Sorry. Here we go. And then next we want to map all of the contracts to their addresses. So and we do so it's going to be a map where we map the address to the contract. And here we will have the known ERC-20 contracts array, and each contract will be mapped to its own address. So we can do this .map, and then C is going to be the contract, and we fetch the contract .address. Yeah, we have the extra parentheses over here. No, let me just call. Let's see what's the problem. String.maps C. Okay, C address, that's exactly. Which okay, contract address field. So we have this field here. That means that we have to use contract address here. Okay. And lastly, we will have the new ERC-20 contracts, and it's going to be also the contract array. So now we are going to go through each block. And this is where main processing happens. So first, we're going to check the block for having the ERC-20 transactions. So we're going to say, sorry, we're going to check the block for having the deployments of an ERC-20 contract. So we're going to say for trace in block dot traces. Where do we need to add fields? Trace. Okay, let's see. Okay, all block dot traces. Sorry. Okay. Weird. ctx.blocks. What might be? So we added the traces. Let's run. Let's see if this. Let trace off. Not sure what this might be. Block string for me. So yeah, exactly. Well, let's see why this is ctx.blocks. I think that maybe let's try running sqd build. No, it's still the same thing. I'm not sure. Blocked. Oh, okay. Oh my god. Yes. Thank you very much. Okay. So we look at each block and we want to see that, and we look at each trace. So we want to see that if tier C dot type is equal to create, that means we have a deployment transaction. And then if there is, so we also, traces also contain the transactions. So if the trace doesn't have the transaction, that means there's an error. So we can log the error. Log. Okay. And if we do have the transaction, then we can check if the address of the deployed contract is already in our known ERC-20 contracts or not. So let's first do get the address. Sorry. And we also need to check if ERC dot create result. So we basically need to check if the, let's see, trace address, transaction index, type, result. Okay, result, and we have, okay, result dot code. We need to check if it is ERC-20. Okay, and okay, we need to import everything from the is. Okay, this is 20 from is ERC-20. Okay, let's do. So now we say that we want to see if the result is true. And let's say that if traces let's also check that the trace is not undefined. Okay. And we need to make sure that this trace is of the right kind. So now we can say that we can add this contract to the array. So new contracts array dot push. And we can push the ERC result address. Undivided is undefined. Okay, let's do it like this. Okay. Okay, let's construct, let's construct the contract, and it's going to be the new contract. And so we have the contract address we can get from the trace, we can get the deployment height from the block. And this is going to be a block number. Oh, sorry, this is going to be the block.header .height. And then what else do we have? We have is ERC-20, going to be true. Then we have the deployment transaction, and this is going to be we can do trc.transaction.hash. And then we also want the so we can push the new contract. Okay, I think this is also we need to add it actually to the non-contracts as well. So we can do this is going to be a map, and we do the same thing where we also set the contract address to the contract. Why is it complaining? Possibly undefined. Okay, so let's also check that it's not undefined here. Okay, and so here we went through everything that through each trace that has a create type, and now we can also go through each log. So I'm not sure why it's complaining, but it does not exist. Partial contract. Oh, okay, sorry. Deployment transactions. So we need to run spt code gen again, and I think it's gonna stop complaining. Okay. So yeah, we went through each block, through each trace in the block to check if we actually got any ERC-20 deployments. So And next we can go through each log to see the transfer event. So for log of blog.logs, so here we want to check that the topic 0 is transfer. So we do the same thing, ERC-20. Oh my god, ERC-20 dot. Did we import ERC? Oh, we didn't import ERC-20, so we also need to import the ABI. So now we can check the transfer event. So we have the topic 0. So we say it should be equal to ERC-20 dot events dot transfer topic. And in this case, we want to create the new contract. So it's either going to be a contract or it's going to be the undefined, and we want to get we want to try to get this contract from the known ERC-20 addresses. That means that we have already seen it and we are retrieving from the database. And we also can check if it's in the new ERC-20 contracts. So if we did get the contract, that means that it is in fact an ERC-20. And we can add, we can get the the event values. So let's say we have, we can go to the ABI and see in the events what we have. So we have from, to, and value. So we can say that from, to, and value equals to into dot events dot transfer. And we can decode the log, and this will give us the from, to, and value attributes. Let's see what else do we need. We need the deployment height, deployment transaction. So let's say height equals to block header height, and then let transaction hash is going to be transaction hash. Okay, let's do this map that you created that's storing all this information where they stored. We are going to save them into the Postgres database in the end. Because, so if you go here, you see that this one, the known ERC-20 contracts, it's actually getting them from the Postgres database, but only those that are that have this set to true, and then the new one is where we're saving the contracts we haven't seen yet, but they do in fact have the right bytecode, and we're going in the very end to save them to our database. So we need the hash, and also we need the, actually let's get the hash. Yeah, okay, we need the hash, and what else do we need? We need the, sorry guys, I'm like a little anxious. Okay, we need to ID contact from to and value. Okay, cool. So we have from to value. Okay, and we don't need the height actually. Okay, so let new contract is going to be a new contract where oh my god, sorry, new transfer is going to be we have the contract is going to be contract, and then we have from is going to be from our log actually, the same for to, and then the value also we got from the event log, and then the ID is going to be log.id. Okay. Don't be oh, thank you guys. I was a little stressed, but yeah. Oh my god. So okay, this is the problem. Okay. Sorry, ID equals log.id. Okay. Contract. Okay, here we go. Yeah, so basically what we're doing here is we're going through each log, fetching the transfer event, fetching the values, and then creating a new transfer entity. And actually I forgot to determine here, we actually do batch insertion to the database, so we can do const transfers, and it's going to be new array of transfers, and this way we can insert it as a batch. Yeah, so we do transfers dot push transfer, add transfers. Okay, and then in the, where's this from? Okay, and then in the very end we can insert the transfers to the database as a batch. And also, since we're keeping track of the contracts, we're gonna do the also insert the new contracts that we saw. Context applies. Okay. Okay, so let's look over the. What is that VS Code extension that shows your errors in the editor? I don't remember, but I saw it. I saw it in one of the like Primogen videos, and I got it. I thought it's like kind of awesome. It's a little bit like stressy, but I think it's also good. Okay, so let's recap. So first we go through each trace of the block, and then if the trace is of the type create, and then if as a result of that create transaction we get the bytecode that corresponds to the ERC-20, we get the result address, we and we add the contract to the new contracts. And then further we go through each log of the block, and we fetch the event, and we check if this transaction that had the event had one of the addresses that we already saw, and if so, then we make a new transfer object, and then we add it to the database. So basically, in the beginning, we get all of the known ERC-20 contracts, and then in the end, we insert the new one. So then when we are here again, we get the new contracts as well. And because the processor is going to receive the chunks of data basically infinitely as long as it runs. So now the last part, you can run sqd build, and then make sure the Docker is running. You do sqd up, and then we need to generate the migration for the database. So you can do migration generate. Okay, and then sqd process, and then you'll start the processor. And here we see that it's running and indexing the blocks. And we can open another window of the terminal, and you can run sqd serve. And this will actually give you a GraphQL endpoint on your 4350 port. So you can go to localhost / GraphQL. And here we see we have contracts, we have the transfers. Let's try. Okay, here we go. So we get so we can see like the address, and for each address we get the transfer of all of the transfers of the ERC-20. So we basically have the relation between the contract and the transfer. So, and we can even check. So let's say, let's see, like we have the values as well. And let's get the address of some of the contracts and go to Etherscan. And we can check that if it is actually an ERC-20. Okay, this is some no-name token. Let's try another one. Try this one. Okay, here it is. It actually does say that it's an ERC-20. Yeah. Okay, let's see. Okay. Localhost A7, I think. Oh, Django. Actually, there is some side project where it's like Squid implemented in Python. So I don't remember the name, but I think if you look it up, it's like Squids in Python. Yeah, I think there is. I don't remember the name. Like, I actually had like someone send me the link to them. Actually, if you want, I can like look it up in a sec. So on the hosted service, I'm guessing I don't need to run Postgres myself. What is the latency there? That's the thing that annoys me the most about the graph. It's very slow. So on the hosted service, yes, you don't need to run the Postgres yourself. And you actually, so here you have like a GraphQL manifest. Sorry, oh my god, the Squid manifest. And here is where you have all of your Squid settings. So if you feel like your Squid is slow, you can say that you specifically want, I think you do something like, you say basically, like you have the scale and you can say how many you want for like load balancing, and you also can say dedicated true, and then you'll have like a dedicated resource, so it will never like be too slow or like fall like below an acceptable speed. So we actually recommend that in production you do dedicated true. On the hosted service, do you have your own ETH node RPC also, or do I need to provide that separate? No, we do have the RPC here. Yeah, you can use this is only using archive, but actually got confused with my Windows. Yeah, so here we're using like the RPC. It's our own RPC, so you can use that, but you can also provide your own. It's up to you. When hosts, I remember seeing. Yeah. So, but you can use any. I think the archive data is free, and RPC is free if you use it locally. But if you actually end up deploying it to Aquarium, then yes, it's going to be charged. But I think the sorry, it's like gonna be pretty high before you need to pay for it. Like probably has latency though, right? Yes, but also it is not it like once your Squid catches up, it's pretty good. So like you basically deploy Squid, it gives you an ETA. So if you go here, you will see that. Wait, let's do view command. Yeah, so you have like an ETA of 35 minutes right here. Once it catches up, like you get all of the archive data instantly, and if you say support hot blocks, you'll even get like unfinalized blocks too. So I think it's pretty good. So yeah, it has latency only like in the beginning. Let's see other questions. Actually, I prefer demos like this over 100% pre-planned copy pasting from a second monitor because I feel like I run into these issues myself. Yeah, exactly. That's how I feel like if I watch the tutorial, then when I try to do something myself, I can't. But also when there's like a lot of people, you get a little bit anxious, as you can see. Yeah, so if you guys have any more questions, you can feel free to write them in the chat. And I think that's about it for this demo. So yeah, as you can see, as it goes on, we get like more and more contracts, and also more and more transfers. So yeah, it does get a little slow, but I think if you query it well, you should be fine. Okay. Do you have a GitHub repo with the final project? I can. Actually, we have. Let me give you. We have a lot of repos. So I think actually we do have it somewhere. So you go to Subsquid Labs. We have a lot of EVM examples. So if you look here, I think, so here's the link. And actually, yeah, this is like I think this is a little bit different, but this is like inspired by this. This is all NFT transfers, so it's a little different, but yeah, this is like the final product, but just a little different. Another question: the graph has a weird limit of only fetching max 1,000 entities per GraphQL request. Is there a limit that like that here also? No. And also you don't have to use our API. You can use anything. Like you can even save to an S3 bucket, and like you don't have to. Not only you don't have to use Postgres, you can make it into like a per-cat file, which is like really good for data science, as far as I understand. Yeah, you can do a lot of things. So we don't have a limit like that. Can I have it stored in data storage that I run myself close to my service? Yeah, you can. If you run the Squid locally, you can store it anywhere. And the SDK is open source, so.
Amazing. Yeah, if you have any other questions, put them in chat. But this was awesome, Daria. Thank you so much.
Okay, thank
I
you.
love that.
Thanks.
And Donkey's worried about your battery life, so plug
Yeah,
it into
but I was right. It's just right. So
just right. That's
yeah,
perfect. I definitely learned a lot. I love the flexibility. I didn't know you could customize the storage, scale it up, all of that. This was very, very cool. I'm gonna have to check this out. We have something at LearnWeb3 that I think this might even be a good like fit for our use case. This is amazing. Thank you so much.
thank you. Thank you for inviting me.
Absolutely. So, guys, if nobody else has any questions at the moment, Daria, where could they reach out to you if they'd like to get in touch and ask more questions?
We have a Discord channel. Let me pull that up. The LW3 course will be released. We have a mini on LearnWeb3, but it covers actually how to set up the template. But I think we are working actually on the, on the, okay, how do I get the link? I'm like not a very good Discord user.
Let me actually check. I think I kind of forgot as well. Oh, I think you just right click on any channel that is public, and it should
Okay,
have an
cool.
option to get an invite link.
Okay, cool. Thanks. Okay,
No
here's
problem.
the.
Perfect. Cool. I'll post all of these links in the YouTube video description. So anybody, if you
Okay.
joined late, if you missed out on something or confused, you can always go back, watch that video. All these links, GitHub repos, Discord links, everything will be there. And with that, I think we can start wrapping this up. So again, thank you so much, Daria. Thank you everybody for coming. I hope everybody learned something. I definitely did. And yeah, we'll keep an eye out on more LearnWeb3 content on this as well. Seems like people like it.
Thank you.
Perfect.
Bye. Thank you very much.
Bye, guys.